It's an instantaneous process, and that is something that wave theory cannot explain. No emission before threshold frequency, something wave theory cannot explain. Number of photons directly proportional to intensity of light, wave theory can. Instant process is एकदम से, instantaneously. Time नहीं लेता, lazy नहीं है. That's what it means, right? Instantaneously, as soon as the light on करी, हमने torch on करी, immediately you'll see the electrons going out. Wave theory says, okay, as soon as you throw the light here, it should build up, maybe 2, 4, 5 सेकंड, maybe 10 सेकंड, maybe 2 मिनट के बाद electrons आएंगे. But that's not happen. That does not happen. Instantaneous. So as light falls, electrons are out. Yes, 10 to the power negative seconds they become. Instantaneous, almost. And that makes sense because photon aa gaya, what are you waiting for? You got enough energy, just go. It doesn't have to make muscles, right? It got energy instantaneously, just release. Wave theory धीरे धीरे देगी, it'll gradually build up the energy, and that is why if you go with the wave theory, it should not be instantaneous, but it is instantaneous. Abhiraj, let's talk about what you're asking. So Abhiraj is saying, what is potential barrier? See, the word potential barrier, the reason I didn't talk earlier is because it doesn't apply here. So this is more like the work function that you're talking about. So there is work function that is defined as the minimum amount of energy that you need to bring this out, right? Potential barrier we'll study when we study semiconductors. So you have a p-type conductor here, semiconductor, n-type conductor here. There is a potential barrier between this, and this is the backbone of everything around you. You and I are having class because of this potential barrier. I'm not overly exaggerating this. All your mobile phones, cameras, laptops, any device, this device, that device, it is just because thank you to the potential barrier in semiconductor. We will study that when we study semiconductors. Yeah, there is a barrier. Barrier क्या होता है? Like fence, right? Fence होती है. जैसे ये दीवार है. This is barrier. मैं इसके पार नहीं जा सकता ना. I need some energy to jump through that. This is barrier. Similarly, वहाँ potential barrier है. So electrons cannot move back and forth. Even if you apply the battery, they cannot move. दीवार खड़ी कर दी. Unless you push a lot and break the wall, maybe. Okay, we will study that when the time comes. Einstein's equation I've already covered. I'm going to show you the printed version of that now. I'm just showing you the slide, not saying anything. Okay, the balance of energy, अगर ज़्यादा दे दिए, that balance of energy is used to give the electron a little all of the kinetic energy, whatever is the balance, because energy cannot be destroyed. If it needs 3 electron volts, but you're providing 5 electron volts, the rest of the 2 electron volts is kinetic energy. It cannot be destroyed. Right, so this is the equation that we covered and we already studied. Okay, so number of photoelectrons with the kinetic energy. So this is the kind of equation, right? Surface electrons have the maximum. So these are the surface electrons, right? Number of, right? So there will be some average kind of kinetic energy where most of the electrons will have, but we are trying to stop these electrons via stopping potential is equal to kinetic energy is equal to this kinetic energy, this. ठीक है, is everybody clear? Nobody is writing anything. क्या हुआ? ये हमने already कर लिया है. No, अच्छा, Arvind Thakur says no, I'm not sleeping. So stopping potential. ठीक है, हमने already कर लिया. Like you reverse the polarity of the battery, and we already did this experiment also. Now I think I'll have to upload more slides. I went faster than I was planning, but I'll use my own slides first. So this is the stopping potential. Okay, Ninad is not very good in Hindi, but he understood my statement. कि सो तो नहीं रहे? नहीं सो रहे सर, नहीं सो रहे. Ninad is awake, right? Yeah, I try to speak a few statements in Hindi. I mean, if that's something really confusing, let me know. I will not use any of the words. It's more like natural, right? The place I grew up in middle part of India, central India, right? So Hindi speaking belt. So I'm more used to Hindi. I was born in Uttar Pradesh. I grew up in Madhya Pradesh, and now I live in Punjab area. So not even Punjab, Chandigarh area. So, but I have been speaking Hindi all my life. So that comes as a natural kind of. Okay. So anybody who did not understand this, please tell me this equation. Yeah. So Arvind Thakur also speaks Hindi, Kannada, right? Ninad is Kannada. Even he uses Kannada in his Hindi. Yeah, that's understandable, right? Your mother tongue or the place you grew up in, that's your more natural kind of. Yeah. And every language is so beautiful. There is no the best language out there or the good language, bad language. Every language is so nice, so beautiful. Diversity is beauty, right? So abhi ye dekho, see, focus on this. This is the graph I was talking about. How many of you have, some students are from NEET exam here. So y is equal to mx plus c. Let's talk about this. So y is equal to mx plus c. Let's take an example here, 2x plus 3. This is equation of a line. How do I know this is the line? Because either power 1 here. This is 1 power. Had this been like y is equal to 2x square plus 3, this is a parabola. This is not a line. It is only line when this power is 1, this power is 1. Okay. Now it is really super duper easy to plot this line. For NEET students, you got to understand this, please. So let me wipe this out so that this is my origin. So y is equal to mx plus c. This is called the slope intercept form. This is the slope of the line and this is the y-intercept. The example I'm taking is y is equal to 2x plus 3. What does that mean? First of all, you look at 3 here. This number 3 tells me that the graph is going to cut y-axis at point 3. See, this 3 is this 3. 1, 2, 3. The line will go through this. The line will either go through this, like this, somehow like this. But it is going to cross that point. This is what it means. Okay. Now, this number 2 tells me the slope. What is slope? The way I really explain my students who are learning slope is slope is equal to rise over run. Kitna rise कर रहे हो compared to run? So here you rise 2 steps. So slope here is 2 by 1, right? So you rise 2 steps, you run 1 step. करते हैं? Like you rise 2 steps, 1, 2, and you run 1 step. So इधर आ गए. So please see here. I have run 1 step and I have risen 2 steps. Same thing goes on. I run 1 step, run is horizontal, rise is vertical, and rise up. And this is the equation of your line. This is the graph of your line. Has everybody understood? Y is equal to mx plus c. Okay. So now if you go back to this, this is exactly like that. See, I'll write it here itself to save time. So y is equal to, I'll write it here. So hold on. So stopping potential is equal to h by e times frequency minus phi by e. Okay. So let's compare this to y is equal to m x plus c, where x is the frequency. X is something I can change. I can change the frequency here, and y is what I'm observing. So here, see, this is the frequency here, and this is the stopping potential. This is y, and this is x. Okay. So now c is the y-intercept, but this is negative, and that is why the intercept is here. This is the work function of this particular material. Yeah, Abhiraj, I'll talk about it. Wait, hold on. Okay, focus here, Abhiraj. That's a good question. I'll talk about the work function of one material, maybe work function of another material, work function of third material. This will keep changing depending on material. This is a property of material. So C will depend on material. However, the slope, is h by e. H I know is 6.626 times 10 to the power minus 34 divided by e is 1.6 into 10 to the power minus 19. Doesn't depend on anything. It's a constant. So rise by run is going to be always constant, and that is why you're going to get these parallel lines always. No matter what is the light color, whatever is the material, whatever, doesn't really matter. Okay. Abhiraj wants to understand more on these slope and so let's take another example. We'll start fresh actually. Okay. So let's take another line here. Y is equal to minus 2 is what Abhiraj is saying. 2x and minus 4, let's say. Both of them minus ले लो, ठीक है? This minus 4 means 1, 2, 3, 4. Oh, let's not take minus because there's no room here. Plus 1 कर लो यहाँ पे, plus 1, ठीक है? So the line is going to definitely go through this point. Slope is minus 2. So rise over run is minus 2 by 1. So when I run one step, I dip two step. Rise is negative. So I run one step, I go to dip two steps. ये second point आ गया. And then I run one step, I go down two steps. ये second point आ गया. फिर run किया, fall किया. Instead of rise, it's a fall. So this equation is बाकी हटा दो. This can be erased, right? So this is the equation of y is equal to minus 2x plus 1. This will be useful when you're drawing photoelectric effect graphs. That is why I'm teaching. I'm not teaching not for nothing. These things you have to understand. Clear? Everybody is clear? No, Abhiraj is really, I don't know why making me more and more challenged. Like, ठीक है, Abhiraj, your question is good. Please continue asking these questions, right? So Abhiraj is saying, what if I take this minus sign and do it here? You don't get a different answer. You get the same answer. So what he's saying, instead of writing minus 2 over 1, let's write 2 over minus 1. That's the same thing, right? It's negative 2. So that means you run backwards and you rise two steps. Run पीछे करो and then you rise two steps. Isn't it the same line? है ना? One step back, two steps up. It's the same line. You don't get any different. Anything not clear, you tell me. That's I'll teach again. Yeah, this is rise over run is how you learn. I mean, I teach mathematics to students in junior grades also. So students who are getting used to slope and all that. I teach it like this, and especially to students who are based in different countries, they don't understand these formulas. Some of the curriculum doesn't go by formula actually, and then you got to go use these words actually, rise over run, or like in calculus. For the students studying calculus in CBSE, it's more like memorizing these things. But the students studying calculus in US and Canada especially, they study calculus much different. It's like scenario based and that's more natural and it comes very easy. Okay. So we'll not spend more time on talking about that. Any question, any doubt, please. Okay, so let me upload more questions, but before that, I'm going to explain you why the wave theory fails. This is a question that many times board exam at least they ask you, and in competitive exams, part of it being asked. So yesterday I was telling you wave theory fails in explaining photoelectric effect, right? And that is why nobody was able to explain photoelectric effect until Einstein said light is both, and now you take it as a photon, everything makes sense. So what happens in wave theory is if you assume light is a wave, I'm going to do it only one time because this is a lengthy discussion. It will go on for at least 10 minutes. So you got to listen here for the first time itself. Okay? So assuming light is a wave, and we know the behavior of wave that you studied in grade 11. Light has intensity, it has amplitude, it has wavelength and frequency, it has so many things, and we know the behavior of waves. So then you say, okay, I have seen that there is a photoelectric effect happens. Nobody actually did detailed analysis earlier, let's say, but then you know photoelectric effect is a reality. When light falls on surface, electrons come out. Okay. Then you say, I will take a piece of paper and I know how the wave behaves, as in what should happen if I increase the intensity of light. I would say this should happen, like more electrons should come out, less should come out, same electron should come out. I know that. Then I would say, okay, what if I change the color of light, as in frequency of light changes, goes up or goes down? Then I list down, okay, if the color changes, I should expect a change in the current or not. I should expect a change in stopping potential or not. And this is all explainable because waves are waves, right? And then you list down other things, and then you're done with your analysis, right? And then you take this list to a lab, and then you make that setup that we did. See, all that setup is made here, and then you say, yeah, I know what is going to happen, because see, theory has to go by experiments, right? So it's like this, it's a nonsense kind of analogy, but then I know velocity is displacement by time. So I know I can write it down. If maybe Abhiraj can do 8 meters per second, I can write it down. If Abhiraj runs for 3 seconds, he will run roughly 24 seconds, 24 meters, right? And if he runs for 5 seconds, I know based on like he will get tired, maybe he'll slow down, and then it should be 40, less than 40 meters, maybe 39 meters. Okay. And then I go and take Abhiraj, and then I take the stopwatch and all that. I do the actual calculations and measurements in the lab, right, or in the field. And then maybe he runs 3 seconds, and I get 25.8 meters. That's good enough because it's in that range at least, right? Some things will be here and there. It will not be exactly same, but then it will be here and there. That makes sense to me. But what happens here is it is completely opposite of that. In that sense, that you wrote down here, that when I increase the intensity of light, current should be same. Current should be same. But then when I do the field analysis, it is completely opposite. No, the current increases now or decreases. Now here I say if I increase the frequency of light, if there was no photoelectric effect, if I increase the frequency of light, no electron should be emitted. But when I increase the frequency, I actually see the electrons are emitted. So the actual observation is completely different than analysis there. It completely fails. It is not deviating. It is like 0 marks out of 100. Has everybody understood what the problem is? And we'll go into details now. Okay. So now let's see why that happens. Let's say there is an electron here which has a certain work function. Okay, it needs, let's say I know it needs 3 electron volts here. It needs some amount of energy. Now, what is wave? Wave is all this energy coming to you, right? Now, if this is, let's say, red light, red color light, right? It's falling on this. I don't see any photoelectric effect. But think about a wave. Wave is continuously giving you energy. At some point of time, अभी नहीं तो maybe 10 seconds down the line, 1 hour down the line, कभी तो इतनी energy इकट्ठी हो जाएगी that it is going to be released. Right? You understand what I'm saying? So wave theory says if there is no photoelectric effect, you keep throwing the same light there, it should accumulate that energy over the period of time. It should release that electron. But this does not happen. So we are not able to explain it why it does not happen. But now let's look at the same scenario from photon point of view. What we were doing here, we were waiting, right? That's all we were doing, waiting. That was the procedure here. Now from photon's point of view, this photon has 2 electron volts. It comes, it tries to release electron. Electron says, I don't like you, just go. It's not like it'll take 2 electron volts and then wait for other photons. It will not do that. It will just discard it. And then you wait more. That's what we were doing. You wait more. You keep waiting. How does it help you? All the electrons that are following, they all have 2 electron volts. And that is why it does not happen. We are able to explain this observation that you keep throwing the light for whatever amount of time. It should, if it doesn't happen with instantaneously, it should not happen after a long time also. Has everybody understood? I mean, I tried my best to simplify this. Shreya Higde, Shivangi, Saigwa, Rukaya, Rupa, Ninad, Manju, Grishma, Attri, Arvind, and Abhiraj. I tried my best to simplify, but I can still do better maybe. I took all the names and nobody responded anything. Understood or not understood. Okay, Rukaya got it. Shivangi got it. Okay, Sai Kumar got it, right? So this is just one example. We are taking more examples now. So let's take more examples. Yeah, Atri beautifully summarized it. Atri said, yes, simply because electron needs a threshold wavelength or a threshold frequency. What you were doing in here is you were giving the same wavelength and same frequency. You are awesome, Atri. Yes, yes. Okay. So let's take that point of view now. So now this is wave theory. I know the light is wave. That's all I know. Light is wave. Okay. I try to do this. An electron wasn't released. It needs 3 electron volts. Okay. Now listen here. Don't type anything. So it needs 3 electron volts. The wave theory says if it doesn't happen, increase. So when I was sitting and analyzing the paper, I wrote it down there, increase intensity of light. Because wave theory says if I increase the intensity of light, that means more energy. So now it should release. It doesn't happen. And I say, okay, I'm really stubborn. I'm going to increase the energy so much. Now you should be releasing. Doesn't happen. Surprisingly, if you take another frequency and tiny little intensity also works now. See, look at what happened just now. I was being stubborn and taking the same color light with lot of intensity did not happen. But then if I take more frequency light with a tiny intensity also it happens. It doesn't explain because wave theory says this has more energy. This should succeed, but this fails. Blue should fail, but it succeed. So wave theory is not able to explain all this. But then look at it from this perspective. This electron needs 3 electron volts. You try to do red color light, you increase the intensity. Increase the intensity as we saw earlier is more photons. It doesn't help it. But then you take blue color light with a tiny little frequency, maybe here and there, few electrons. That's good because now this has 4 electron volts. It succeeds. So this is, you can see, I mean, this is how you're able to explain now. As soon as you say photons, yeah, that makes sense. ठीक है